Welcome to Lesson 3, Applications of Systems. This is going to be part 1 of 2. This one is going to be focusing on reviewing solving systems by substitution and graphing. You'll also see that on top of reviewing, we're also going to review how to model situations with equations. This is what we were doing in Unit 4A. So it constantly builds on itself. Then we're going to go into actually solving the word problems and interpreting the meaning of them. So this lesson doesn't have new content. It's actually just combining all of our past content into one. So without further ado, let's go on to the first exploration. So here's our first exploration, and you're going to see that I want you to take about 8 minutes on this. Now, the following two equations represents the supply, this is economics, how many there are, versus the demand, how many are wanted for 3-bedroom rental apartments in Chicago. Notice how I define the variables. And what I'm asking you to do is I'm asking you to use substitution to solve this system and then interpret the meaning of the solution. So I want to see what you think before I go over it. So take 8 minutes and see if you can solve this system and interpret the meaning. So I hope that we remember that the reason why we can refer to this as a system is both equations are dealing with the monthly rental price based on the number of apartments demanded in thousands versus supplied. And since we're trying to figure out when those equal, that's why we can use the same variable. So since we use substitution, well, we've actually solved both of them for P. So we can actually say all of a sudden that negative 50x plus 2000, which is equivalent to P, and P is also written as 50x. So we can write it as that. I can then all of a sudden add 50x to combine like terms, get 2000 equals 100x, divide by 100, and get x equals 20. So if there are 20, in thousands, so 20,000 apartments, well, they're saying solve the system, interpret the meaning of the solution. So I have the x, let me find the y. So I'll say P equals 50 times 20, because I'm just substituting in. It doesn't matter which one I use. P equals 1,000. So if I now want to interpret the solution, which is all of a sudden 20, 1,000, if the supply and demand of apartments is 20,000, because it's in thousands, the monthly rent will be $1,000. So there's our first exploration. If you don't have this in your notes or you got it incorrect, make sure you add it. And if you have questions, come and ask me. Otherwise, I have an example for us to go over. So here's our first example. Now, when we're dealing with systems of equation word problems, we need to think of the two situations because there's going to be two equations. So we're looking for two sentences we can write, two mathematical equations. And when I read this, I see the word is twice. Well, is means equal. So when I take a look at the first one, and let's start, so we've told that we want x to represent our first number and y to represent the second number. So if all of a sudden I look at the first sentence, and the first sentence is here, the sum of twice a number and 4 times another number is 4. So the sum of 2x plus 4y equals 4. And then the first number decreased by the second number, so the first number decreased by the second number, is 5. Now, we were asked to solve this by graphing. So there's many different ways of doing this. I'm going to do it in 2 different ways. I'm going to rewrite this in slope-intercept form. So I have a 4y equals a negative 2x plus 4. Divide everything by 4, and I get y equals a negative 1/2 x plus 1. So I'm going to do this one in orange. So I have a y-intercept of 1, down 1 over 2, down 1 over 2, down 1 over 2, down 1 over 2. Again, the idea is so it'll be easier to visualize. So up 1, back 2, up 1, back 2, because I'm just doing the reverse. Okay. Now this one, I'm going to do it by finding the intercepts. Again, there's so many different ways. So if I plug 0 in for x, well, all of a sudden, I then get that negative y equals 5. So y equals negative 5. So 0, negative 5, 1, 2, 3, 4, 5. And then all of a sudden, I also get, when I plug in a 0 for y, I just get x equals 5. Okay, 1, 2, 3, 4, 5. And all of a sudden, oh, I see that this right here is my solution, and that is 4, negative 1. So what are my 2 numbers? The first one is 4, the next one is negative 1. Make sure you have this solution, this example in your notes before we move on to practice. So I have 5 practice problems for you. Now I'm going to be walking you through some of them through the questions I ask in Play Pause It. At times you might type in your equation slightly different, so it might mark you wrong because as a reminder, I have to put in them all. So I will be following along, and if I see you have the correct equation, I will mark it correct. So if you see that yours just maybe is in a different order, don't see incorrect as you being incorrect. So here's practice 1. Take about 10 or so minutes. Best of luck. So when we take a look at this, we see that 11 times one number, I'm just saying x is my first number, so 11x is 9 more than 8 times the other number, so that's 8y plus 9. Then we see that 4 less the first number, okay, so x minus 4, is half the second number. Now I asked you to solve this using substitution. Now, when we do it, solving for this x or y isn't going to be great because we're going to have to divide by 11 or divide by 8 to get to just y. So I'm going to use the second equation, and you could do this 2 different ways. I can either solve this one for x and get x equals y over 2 plus 4 by bringing the 4 to the other side, or I can actually multiply this whole equation by 2 and get 2x minus 4 equals y. So now I'm going to give you a moment to solve the system. Go ahead. So it doesn't matter which one you used. I'm going to use this one for the sole purpose of not having to deal with fractions. And I'm going to substitute this in for y. So I now have the equation 11x equals an 8 plus 9, and this is a 2x minus 4. I can then solve it. 11x equals 16x minus 32 plus 9. I'm going to subtract the 16x to the other side. Again, negative 5x equals, well, negative 32 plus 9 becomes a negative 23. We'll divide by negative 5, divide by negative 5. X equals a 4.6. I now need to solve the other one. It makes sense, again, as I was saying, always use one of the original ones. So I'm going to use the x minus 4. So I'm going to say 4.6 minus 4 equals y over 2. 0.6 equals y over 2. multiply the whole thing by 2, and I got y equals 1.2. So 4.6 comma 1.2. These are the solutions to my two numbers. All right, let's go on to practice number 2. This is one that I'm going to be walking you through the play pause it. So if you realize that you get one part wrong and then see the feedback and use that feedback to then try the next part. All right, go ahead. So here's the solution. As you see, my first part was defining the variables and modeling the two topics. One was the cost. That's this one right here, modeling the cost. And the other was modeling the number of animals. That's this equation. I then was able to rewrite the one on the right in terms of x. You could have also done it in terms of y. I then substituted for y, or substituted for x, and I was able to figure out that y equals 15 in part B. Part C was substituting that in for y and solving for x, which was 12. And part D was writing my sentence. All right, let's go on to the next practice problem. So this is using a new vocabulary word called complementary angles, which means their sum of the two angles is 90. So give this a shot. Here's the answer to practice 3. So again, hopefully the walking through sort of helped. I've defined my variables. Since they are the measurements of 2, what we're seeing here is this one right here just represents the fact that the 2 add up to 90. They are complementary. Whereas this one shows the comparison between the two. All right, we found y by substituting. I then found x by substituting, and I wrote my sentence. Here is practice problem 4. I'm going to keep walking you through it. Again, use that feedback to help you as you go. So we had two equations, one which represented the cost of Tim, while one represented the cost of Vodafone. Right in here, I solved it and got x equals 17. 17 is the number of months. Well, then I substituted it in and I was able to get y equals 173, which is the cost. And what this means is after 17 months of service, both plans cost the same. So if you want to plan for longer than 17 months, then go for the one that then ends up being cheaper, because each month after that, Vodafone costs 9, Tim costs 8.25. So Tim would be 75 cents cheaper. If you're only going to want to plan for a year, well, then actually it's cheaper to do Vodafone. And so that's how we then take it a step further and interpret the meaning of the solution. So I have one more practice problem for you. Here it is. Go ahead. So here is the answer key to the last and final practice problem. We see that we have one equation that shows the relationship between the hours, while one shows the relationship between the money. I was able to solve the one on the left for y. I could have done x. The second equation, I'd have to divide by 9.5 or 7. So again, that's why I'm not using that one. I determined that x equals 16 and used that to solve for y. And then finally wrote my equation. So if you have any questions on this, make sure that you reach out to me immediately. We will have more practice for this. Otherwise, for now, enjoy the rest of your day. Bye, everyone.